Okay, this is topic 30, chain rule. So chain rule is just another way to derive a function, but in this case we're going to use the chain rule every time we have a function within a function, or a composite function. So for example, if we have a definition of f of x here, capital of f of x is equal to f of g of x, alright, this is a composite function, or you can say this is a function within a function, okay? So to take the derivative, we would take the derivative of the outside, notice that the outside function is f, times the inside, times the derivative of the inside function. Alright, so this is what they're talking about, derivative of the outer, and then we have times the define out the inner, that's when I said times the inside function, that's what I mean by that. And then we have times the derivative of the inner function. Alright. So let me just show you a few examples tonight. Hopefully that'll make more sense. So if we have a function that looks like this, all right, we actually have a function within a function. The outer function would be 2x plus 1 to the 5th power, and the inner function would just be 2x plus 1. All right, so as soon as I see something like this, I know that I can use the chain rule. All right, so if I'm going to use the chain rule, the derivative of this right here would be the derivative of the outer. All right, notice that the outer, let me actually erase this real fast, maybe that'll make more sense. The outer function, the derivative of the outer function, which is 5 something to the 4th power. So this is almost like using the power rule, right? You bring that 5 down, you subtract 1 from the power. Now it says define out the inner. So the inner function, I'm just going to rewrite that inner function. So when I say the chain rule is the derivative of the outside times the inner, right? So this is the inner function, times the derivative of 2x plus 1, or the derivative of the inner, which in this case would be 2. Alright, so the derivative of 2x plus 1 is just 2. And then after that we can simplify if we can, so we got 5 times 2, so we got 10 2x plus 1 to the 4th power. And that's really all we're going to do with that. Alright, let me show you another example. So now if we have let's see, I can rewrite this as y is equal to x squared plus 1 to the negative 1/2 power. Alright, so I'm going to rewrite it like that. So one more time, we have a chain rule, alright, where the outer function is going to be this right here. The inner function would be x squared plus 1. So now to take the derivative, alright, we're going to take the derivative of this, so that would be negative 1/2 to the power of negative 3/2, and what goes in here, remember, is the derivative of the outer, define out the inner. So the inner part of it is x squared plus 1 times the derivative of x squared plus 1, which in this case is 2x. Okay. And if we try to multiply what I have here, I would have 2x times negative 1/2 will give me just negative x, times x squared plus 1 to the power of negative 3/2. But I don't want to have that, right? So I don't want to have a negative exponent. So I can rewrite this as x over x squared plus 1 to the power of 3/2. Negative x right there. Okay. One more. So on this one, every time you see, hopefully you understand this one now, on the third example here, we have y is equal to sine square x. Alright, so just to make sure we understand, sine square x is the same thing as having sine x squared. That's the same thing, alright? They're exactly the same. So if we have that, then the outer function becomes this, and the inner function is sine x. Alright, and now we're gonna use the chain rule. As soon as I see a sine square or a cosine square, for example, or a tangent square, any of those trig functions square, a lot of the times I can use the chain rule. Alright, so on the chain rule, what I'm gonna do is I'm gonna take the derivative of the outer, which would be 2 something blank to the 1st power, right? And now I'm gonna define that at the inner, so it's gonna be sine of x times the derivative of sine x, and the derivative of sine x is cosine. And I'm just going to rewrite this as y is equal to 2, the derivative of y is 2 sine x cosine x. Now on here, on this notes, and sometimes in the quiz, and sometimes over the test, you may get the right answer, but they're going to rewrite the same answer like this, as sine of 2x. And this right here is a double angle identity, I believe. So, we can review this when you do this, probably by Tuesday or Wednesday we can talk about this, okay? Anyway, so that's what that is. So remember, between here and here, I use a double angle identity. Alright, so this is right, but this is also correct. So on the next one, if you have a tangent of 4x, what that really says is that the outer function is the tangent. Alright, the inner function is the 4x. So now, once we know that, we're going to take the derivative of the outer. The derivative of tangent is secant square. Okay. Now remember, right here we're going to put the inner function times the derivative of 4x. The derivative of 4x times the derivative of the inner, don't forget, would be just 4. So the answer on this one would be y prime is equal to 4 secant square of 4x. And that's it for that. Okay, so now let's go over to the back. So again, don't forget that the good thing about recording is you can go as fast or as slow as you can. So if you don't understand what I just did, I would recommend rewinding just a little bit and rewatching that, alright? Because then this is going to get more difficult. So I need you to understand that first page. Alright, so again, go back if you need to. So this right here would be the same thing as x squared 9 minus x squared to the power of 1/2. Okay, now before we even start, let me tell you that you cannot distribute that x to the 1/2 power. You just can't, alright? And then no, you cannot, this is not 9 to the half power and this is not x to the 1 power. It's not, you can't do that. Alright, so on this one you really have no choice. You have, notice that right here, you have a function, x squared, times another function. Now this other function right here actually is going to require this 9 minus x squared to the 1/2 is going to require for you to do the chain rule. So one more time, within this one I have a product rule, and this one, to take the derivative of the second function, I'm going to use the chain rule. Alright, so we have a product rule and a chain rule all in one problem. So let's start off, let's just worry about the product rule for now. So we have the first, which is x squared, times the derivative of the second. Now the derivative of 9 minus x squared to the 1/2 power, for that I'm going to use the chain rule. So I'm going to write something over here to the side to make sure that I don't lose you here. So if I'd say that this right here is f of x, and this helps some people really doesn't help, but if it helps you, you might want to at least write this down so you know which one's the outer, which one's the inner function, okay? So if I say that f of x is this, the outer function would be the outside, well, let me erase this. I would just have, this would be your outer function, that quantity to the 1/2 power. Alright, and the inner function would be 9 minus x squared. Okay? So now, the derivative of this right here would be 1/2 times the inner to the 1/2, to the negative 1/2 power, like that. Alright, and the derivative of this, which is the outer, this is the inner function, would be negative 2x. Alright? So remember, now, if I take the derivative of this now, remember, the chain rule says is the derivative of the outside, which is 1/2, that quantity to the negative 1/2. And what goes inside here is this original part. This would be g of x if you're looking at the formula. 9 minus x squared. Okay? Times the derivative of 9 minus x squared, which is the inner part of the function. So we have times negative 2x. So now we're getting back to the product rule. So remember, we have the first times the derivative of this, which is what we have here, plus the second, which in this case is just 9 minus x squared to the 1/2 times the derivative of x squared, which is 2x. Okay? So now let's try to simplify this. So just to make sure that we understand what this came from, remember, what I just did here, all of this is a product rule. This right here, I had to use a chain rule to get the derivative of this part right here. Okay, so this again is a chain rule. Okay. Okay. So now I'm going to try to simplify what's inside of that first. So let's see. Notice, so I'm going to do something here. Definitely something. Alright, if I multiply this times this, I'm going to have a negative x. And if I multiply that negative x times that x squared, that's going to give me a negative x cubed. Alright, so again, I did this first, and I multiplied times that. Times 9 minus x squared to the negative 1/2 power. Plus, this right here is not really anything I can do, so I'm just going to rewrite this. I'm just going to put the 2x first. Okay. Okay. So now I definitely do not want a negative exponent, so I'm going to write this as negative x cubed over 9 minus x squared, the square root of that, so I switched that from a negative 1/2 to a positive 1/2, but I wrote it as a square root. And on this one I have plus 2x 9 minus x squared. Alright, now normally if you have multiple choice or whatever, you see it, okay, you will be done. But let's say that this answer does not look like that answer in your this is not one of your choices on the multiple choice. So in that case, normally what happens is that they want a common denominator. They want to add this together. So to add this together, you need a common denominator. So I'm going to multiply top and bottom by the square root of 9 minus x squared. Okay? And then when I do that, this right here is going to remain the same. Now this right here I'm going to have plus 2x. Now this right here, when I multiply this times this, that's going to get rid of the square root. So I'm going to end up with 9x squared, 9 minus x squared over this. Okay. Now I'm going to distribute that. So I have negative x cubed plus 18x minus 2x cubed all over 9 minus x squared. So I went ahead and wrote all of this under the same denominator. And if you had like terms, you would have negative 3x cubed plus 18x over the square root of 9 minus x squared. So again, sometimes it's not necessary to do all of this simplifying. I'm going to provide for you the answer key for this homework, which is 30, I believe. Yes, it's 30, so that way you'll know how far you need to go. Okay. Now in the next one. Now the next one, if you look at it, I have a quotient rule here. I have a function on top, a function on the bottom. Now on the bottom, all right, on the bottom I have it's a quotient rule and a chain rule. Right? On the bottom, to take the derivative of this bottom, I am going to have to use the chain rule, alright, because I have a outer function, which is this quantity cubed, and the inner function is x squared plus 2. So, before we begin, let's just talk about that. So if f of x, this would be the derivative, okay, if this is the outer function, the inner function is x squared plus 2, then the derivative of this right here would be 3 times that quantity squared, and that quantity being this, but I want to keep this as simple as I can, and the derivative of this would be 2x. So this is the stuff that I need for my chain rule eventually, alright? So now I'm going to take the derivative of this. So remember, it's low d high minus high d low over low square. Alright, so the first thing I need to do is low, which is just rewrite the bottom power of 3 times the derivative, so it's low d high, the derivative of x is 1, minus high, which is x, times the derivative of the low. Now the derivative of this right here is what I need this chain rule, right? So to take the derivative of this, I would have 3. Now on the inside of this parentheses goes x squared plus 2. Now one more time, you don't need to write this if you don't have to. Maybe at the beginning you're going to have to, but then later on you're going to get so good at the chain rule because we're going to use it over and over and over again that you may not have to do that anymore. Alright, so do as you wish, use it if you have to, but if you don't have to, then you don't have to write this necessarily. So times the derivative of the inside function. The inside function, the derivative of x squared plus 2 is 2x. Okay? Now don't forget that this little piece right here, I had to do that to take the derivative of the low, so this I had to use the chain rule. Okay. And then now over the low, and I have to square that. Okay. Now I'm going to have to distribute all this stuff, simplify as much as I can, so I have y prime is equal to x squared plus 2 cubed minus, how do I want to do this? Alright, so notice that this right here, I'm going to leave this x squared plus 2 to the power of 3 alone. All this, notice all this is multiplication, so I have negative x times 3 times 2x, which is going to give me negative 6x squared times x squared plus 2 cubed. Oh, sorry, square. What would I write cube there? I'm sorry, that's supposed to be a square right there. My bad. So this is a square times 2x. Wait, I don't know what I'm doing. I'm looking at the wrong part, I'm sorry. So I'm sorry, this is it. Okay, so sorry, I originally made a mistake. That should have been a 2 like I have here. And then I just have to multiply negative x times 3 times 2x, which gives me that. Okay? Now all of that, x squared plus 2 to the 6th power, right? Because we have a power to a power and multiply. Okay, so this part right here might be a little weird. Sometimes you need to do it, sometimes you don't. Again, one more time, more than likely in this homework and this test and the next few quizzes, you're going to have to do that. So right here, there's one more thing I can do. I can actually factor, right? Notice that this is one term right here. This is another term. What do they have in common? Well, what I have in common is the x squared plus 2 squared. So I'm going to factor an x squared plus 2 squared out of this, which is one term, and out of this, which is the second term. So this will give me x squared plus 2 to the first power, alright, minus 6x squared, all over x squared plus 2 to the 6th. Again, so at the top what happened is I factor out the smallest one of these, which in this case is x squared plus 2 squared. Okay, so now, notice that right here, by the way, the parentheses is kind of pointless. The parentheses is just there, but it doesn't do anything. I'm going to add like terms in here. Okay, and then, so I'm going to add like terms here because I can. Now this one right here, what we're going to do is that, notice that we have the same thing here. Alright, but this is to the 6th, that's to the 2nd. So all of these will cancel 2 of these, and I would have a 4. Alright, so again, all of this is going to cancel 2 of these, so I end up with x squared plus 2 to the power of 4. So, again, I'm going to add like terms. Notice that I have x squared minus 6x squared, which will give me negative 5x squared, plus 2, which is that 2 right there, all over x squared plus 2 to the power of 4. Alright, so this will be my answer. Again, sometimes you may not know when to stop. I'm going to show you the answer, so that way you know when to stop, right? So maybe you have done everything right, but you need to keep on simplifying. As always, I think the hardest part on this is obviously the algebra, so if you have any questions, make sure and ask me, okay?